These fuels are the workhorses of modern life. They sit in kitchens, fuel our taxis, and cross oceans in vessels larger than aircraft carriers. But the acronyms used to describe them, LPG, PNG, CNG, and LNG, are frequently confused. Mixing them up in the real world is dangerous. Because each gas behaves differently when it hits the atmosphere, knowing exactly which one is leaking determines how you respond to the emergency. For students, the stakes are also academic. Technical definitions of these fuels are a recurring fixture in competitive exams, often appearing as subtle trap questions that test whether you know the specific chemical makeup of natural gas. To keep them straight, we have to look past the metal cylinders and pipelines. To understand how they work and why they matter, we must divide their invisible molecules into two distinct chemical families. We can visualize these fuels on a family tree. On the first branch, we have the petroleum gas family, consisting of propane and butane. We know this as LPG. On the second branch is the natural gas family, which is built around a much smaller, lighter molecule, methane. LPG stands for Liquefied Petroleum Gas. It is a mixture of propane and butane, and unlike natural gas, it is typically a byproduct separated during the refining of crude oil. To make it easy to store and transport, engineers apply a relatively low pressure, roughly 12 bar. This forces the gas to condense into a liquid, which is the L in LPG. Because propane and butane are relatively large, heavy molecules, LPG is heavier than air. If a leak occurs, the gas doesn't float away. It sinks, pooling at floor level and spreading across the ground like an invisible liquid. Before it reaches a kitchen cylinder, LPG is stored at massive scales. Refineries use these spherical white tanks because the geometry allows them to withstand the internal pressure required to keep the gas in a liquid state. This ability to liquefy at low pressure makes LPG highly portable, which is why it revolutionized heating for off-grid homes. It just requires strict floor-level ventilation to manage its density if a leak occurs. Now we look at the other branch, natural gas. Its primary component is methane. Methane is much lighter than air, meaning it behaves the exact opposite of LPG. If it leaks, it immediately rises and disperses upward. The simplest way to deliver methane is through a pipeline, functioning like an on-demand water supply. This is piped natural gas, or PNG. It requires no local storage, you simply turn a knob and the fuel flows. However, you cannot attach an underground pipeline to a moving vehicle. To use natural gas for transport, we have to find a way to pack those light methane molecules into a compact fuel tank. One solution is extreme pressure. By squeezing methane at roughly 200 to 250 bar, we can crush its volume down 200 times. This creates CNG, compressed natural gas. Because it burns cleanly and fits into high-pressure tanks, CNG has become a standard for urban transit. You'll see it marked on the back of buses and auto rickshaws across the world's major cities. But even 200-fold compression isn't enough for international shipping. To move methane across oceans, we use cryogenic freezing. By chilling the gas to negative 162 degrees Celsius, it turns into a liquid. This is LNG, liquefied natural gas, and this process shrinks the volume 600 times. Maintaining that liquid state requires specialized cryogenic insulation. These international carriers are essentially giant floating thermoses, designed to keep the cargo frozen for weeks at sea. Chemically, PNG, CNG, and LNG are identical methane. We simply use pressure and temperature to solve different logistical problems. To lock these differences in for an exam, we can organize them into a definitive reference grid. For chemicals, LPG is our propane and butane mix. The others are all methane. For their physical state, LPG and LNG are liquids, while PNG and CNG are gases. For delivery, PNG uses pipes, CNG uses high-pressure cylinders, and LNG uses cryogenic ships. Crucially, LPG is the only one in the group that is heavier than air. This matrix covers the core technical differences you'll face in a competitive exam. If you can visualize this grid, you can answer any question on gaseous fuel properties. Natural gas is often marketed as a cleaner fuel because burning it emits significantly less carbon dioxide and particulate matter than petrol or diesel. But there is a catch. If unburned methane leaks from a pipeline, it becomes a powerful greenhouse gas. In the short term, it is far more effective at trapping heat in the atmosphere than carbon dioxide. Each of these technologies solved a specific logistical hurdle. LPG brought heat to rural areas, PNG modernized city kitchens. CNG reduced urban air pollution. LNG connected the global energy supply. Now that you've seen the data, let's test your memory. If you're in a room with a gas leak and the gas is pooling on the floor, which of these 4 fuels are you dealing with? Post your answer in the comments.